Okay, so today we're going to look at a different type of chemical reaction, and we call this one a precipitation reaction. It's not to be confused with when you're talking about weather. When people do weather forecasting, they might describe, precipitation happening in the west. They're talking about rainfall. You have to think differently in chemistry. We use the word precipitation, we mean it differently. A precipitation or precipitation reaction is when you have two aqueous solutions and you mix them together and you form a solid. Now that solid will typically look like a cloud forming between the two. So for example, these two bottles here, you can see they're completely transparent. They look very much like water. However, depending on which chemicals I mix together, we'll just get a completely different color. Or even if it's not colorful, it'll just be like a white cloud forming. And that's because we are basically mingling together some of the separated or dissolved particles of these two reactants, and some of those reactants may find each other very attractive, and so attractive they actually form solids. They'll have a really tight bond between the two, and they will separate out of the water. And then that'll usually have a bit of a trickle-down effect, so it'll eventually settle towards the bottom if you leave it still for a long enough amount of time. So I've got a few combinations here. I've tried to find some of the most pretty and the most beautiful, colourful ones I can, and I hope you get to enjoy. Let's take a close-up. Okay, for our first reaction here, I'm going to have sodium iodide mixed with lead nitrate. So let's put in the sodium iodide. It tends to have a bit of a yellow tinge from the iodide compound. The sodium iodide compound here is quite transparent. You can see quite through it. It's just a little bit yellow. So now we're going to add our lead nitrate. And I'll just add a few drops. We can see that where the drops met at the surface, we have the precipitate forming, and hopefully on the camera you can start to see that it'll eventually start raining down and settling out. I just want to reiterate to you folks at home that the chemicals that we started off with were very transparent, and what we end up with is a chemical that is not very transparent at all. It's actually a solid. That's all. Hopefully it's starting to settle down on the camera. I'm not sure if you can pick that up. But we could see that the original chemical, obviously my bottle here is empty, but originally we started off with a very transparent liquid, and then I added this also very, very transparent liquid, and yet we have this solid being formed. Now this solid, that is what we call the precipitate in this chemical reaction, which will probably be lead iodide. And we'll carry on to the next one. Okay, this time around we're going to have these two chemicals. We've got copper sulfate versus sodium hydroxide. Now these are both very transparent liquids. Obviously this one here has a bit of color, so I just want to give you guys a better view of this, where you can see quite clear that it's a very transparent liquid. Just going to pour in as much as I can here. We've got a very dilute solution of copper sulfate. Normally it's a very intense, almost as blue as my glove when you have a higher concentration. And now I'm going to add the sodium hydroxide, which is very much transparent like water. And then I want you to have a look very closely at what happens. So now we can see that the solution is no longer transparent, so you can't see very clearly through it. We have a bit of a blue cloud, so it's very likely that our precipitate, the solid formation, is properly copper-based, because copper usually has this beautiful blue colour. And again, if we leave this for a bit of time, we'll start to see those particles, those little solid particles will eventually start to settle. But I think I might carry on to the next one here, so we can get a look at another one. Okay, this one here, our last demonstration, is going to be a combination between barium nitrate and sodium chloride. Hopefully there's enough solution here for it to work. Now, I've got a feeling this one here is probably going to be a white colour. So if that's the case, I'm just going to add the barium nitrate now, and you can see that's very much like water, completely transparent. However, just if in the occasion that it does perform a white precipitate, I've just got a bit of black cardboard here to provide a bit of contrast in the background. So hopefully you're able to pick that up on camera. So I'll just put that up nice and close. Might put it that way so we can get a bit of lighting. Okay, here we go with our second reagent, which is sodium chloride. Just going to add a few drops. Okay, so we can see that we don't have a chemical reaction between these two. So let's talk about that. Well, this is going to come down to solubility rules, where we notice that certain combinations of ions, so barium ions, nitrate ions, sodium ions, and chloride ions, there's actually a table you can look up and determine if you have certain combinations present. So for example, I have barium and nitrate, and I look it up on the table, we see that that combination is soluble, or has high solubility, hence why it's dissolved. Here, I could look up sodium and chloride and look at that combination on the table and find that it is also very soluble, hence why it's dissolved. If we look at some combinations, once we mix the two, well, we could have a combination of barium and chloride, and we look that up, it's soluble. We could also look up another combination of sodium and nitrate that is also soluble here. So this is actually my mistake. I've actually chosen two chemicals that clearly wouldn't actually form any precipitates or any product that has low solubility. So I'm actually going to see if I can modify this slightly and find something that will pair really nicely with these two. So here's what I was referring to earlier about using a solubility table to determine whether the combinations, the possible combinations we get, to determine whether they will be a soluble product, meaning they'll stay in solution, or whether they will form a low soluble product, which will very likely form a solid, which is what we call a precipitate. So let's use barium nitrate as an example of how to read this table. Barium nitrate was one of our reactants, so we know it was dissolved or soluble, but let's just look up this table and I think you'll start to see of how this whole thing works. We start off with a negative ion, and then we find its row, and then we read horizontally to see what pairings with that negative ion and what result we'll get out of that combination and whether that compound would be soluble. So barium nitrate, our negative ion is the nitrate, so we find the row, and we read horizontally, and basically all pairings of any positive ion with nitrate would be soluble, which matches what we saw in reality. Now let's turn our attention to our chemical reaction, which had two reactants. Now when we mix them, those ions can mingle and possibly find new partners and therefore a new combination. One of those possibilities is that we could have barium chloride. So we look up chloride on the left-hand side, we find its row, and now we read horizontally, we can see that if you pair it with silver, lead, mercury, or copper, then you would have low solubility. However, we did not pair that with any of those positive ions. Our ion was barium, and that fits into the all others category. And we read across and it says soluble. Oh well, too bad. Let's try the other possible candidate, sodium nitrate, as a possible new compound from that mixture. So again, we find nitrates, and you might recall, all other pairings with nitrates, basically all nitrates are soluble. So that's why we didn't get any result from that just previous example, our demonstration. So now the question is, what can I do to try and find something else I can mix in here so I can actually show you something meaningful as my third demonstration? So what I did in the lab is I used this table here and I went searching on this thing. Okay, can I find one that I can readily find in the lab that would form a precipitate? I actually looked up for carbonates. So I looked on the left-hand side, found carbonate. If it's paired with lithium, sodium, potassium, rubidium, or ammonium, then it will be soluble. Luckily, I didn't pair that. We're going to pair that with barium, which falls into the other category, and therefore low solubility. So theoretically, this should work. So I've swapped out the sodium chloride for sodium carbonate. So let's give this one a shot. There we go. So this is more the standard type of precipitation you'll find. A lot of chemicals will combine to form white precipitates. To get the really interesting colors, you would have to find solutions involving some more of the transition metals. So that's going to be things like iron, copper, zinc, and so forth. That region of the periodic table is typically responsible for a lot of the beautiful colors, like in paint. So there we go. We got 3 examples of precipitation reactions. We could see that on each occasion there, we actually formed a cloudy-like substance when you've mixed 2 aqueous solutions together. Usually the starting solutions are completely transparent and you tend to form, in most cases, it'll be a white cloud. However, if you're lucky, with a transition metal present perhaps, you might get these beautiful colors as well. Hope you've enjoyed this, everybody, and I will see you in the next video.